Today we're going to be discussing Zigbee wireless I/O pairing, how to trigger outputs based on inputs. Here's our agenda. We'll first introduce Zigbee wireless technology and then go over Modbus RTU and Modbus TCP over wireless, followed by how to trigger outputs based on inputs, and then finally we'll show you Zigbee I/O pairing applications, and lastly we'll demonstrate using Zigbee I/O with Easy Data Logger. If you have any questions at any time, please enter them in the chat box and we'll answer those questions at the end of the presentation. ICP-DOS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICP-DOS USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers. We work closely with them to add new features to our products and develop new products and support our customers. Most of our products are RoHS compliant, which means they are lead free. We have ISO 9001 certification, which ensures we meet product statutory and regulatory requirements. Industrial wireless communication opens up many new possibilities for highly flexible and efficient automation solutions. They are suitable for indoor and outdoor use, and when used in the field of remote control and remote maintenance, they bring outstanding benefits. Zigbee is based on the IEEE 802.15.4 standard for wireless personal area networks. Zigbee lets you easily and cost-effectively add intelligent new features that improve the efficiency, safety, security, and reliability of your products. A Zigbee network requires a device to act as a coordinator. The coordinator's role is to direct messages to the intended slave or router device. In the picture shown, the PC is sending serial data which is being transmitted wirelessly to the ZT2551 and the ZT2000 I/O modules in this scenario. For industrial networks, the host is traditionally connected to the master PLC or PC to pass data wirelessly to the router or slave modules. The chart at the bottom shows our selection of host and coordinator modules. We have selections for both Ethernet and serial. At the bottom we also show a USB option, which is great for configuring the I/O modules that we will show you shortly. The following networks are supported by Zigbee. The star topology, where the coordinator is in the middle and talks directly to the routers, and the mesh network type, which the Zigbee coordinator is connected to routers and data is passed along from router to end devices using Zigbee technology. We also support cluster tree topology, which is shown at the bottom, which incorporates a combination of both. Our Zigbee host converters have been used in many applications worldwide, including creating wireless bridges between serial data between buildings, extending networks wirelessly, and we also have a wireless Modbus gateway feature built into our Zigbee modules, in which data can be converted from Modbus TCP to Modbus RTU, or from Modbus RTU to Modbus TCP. Modbus started off as a serial-based communication protocol that was created by Modicon in 1979 for use with PLCs. It's widely used in industrial communication for instrumentation, control, and data acquisition devices. Zigbee allows masters to communicate without wires to Zigbee slaves and I/O devices. Modbus TCP was developed later to be adapted using Ethernet communication instead of serial communication. Here's an application diagram of a typical Zigbee application. The ZT2570 at the bottom is connected to a PLC or SCADA system and is collecting data and reading data from Modbus slave devices connected to our ZT2571 at the top and our Zigbee IO modules, our ZT2053 on the left side. The ZT2571s also act as repeaters to help bridge communication between devices. As I mentioned earlier, we also have Modbus gateway features built into our Zigbee modules. In this application diagram, the Modbus TCP SCADA system is connected to our ZT2570, which is collecting data from Modbus RTU slave devices and transmitted wirelessly to the ZT2570. The data being read in from the SCADA system will be Modbus TCP format. We also have the opposite solution, where the PC connected to the ZT2570 is looking for data in Modbus RTU format. The data is being read in from the slave devices as Modbus TCP, and then the ZT2570 will convert the data to Modbus RTU to be read in by the PC. Next, I would like to show you our Zigbee IO modules. These modules provide wireless remote IO that's built into these modules. They communicate wirelessly to the host converters in most situations, and I'll show you some unique applications where we created custom firmware to use these with other devices. The basic ZTIO modules communicate data wirelessly via Modbus TCP format, via Modbus RTU format, or by DCON. When using Modbus TCP, the conversion is done in the gateway. Our Zigbee IO modules, as I've shown previously, provide wireless remote IO to the host coordinator. Data can be read in by Modbus TCP format with the conversion done in the gateway, via Modbus RTU, or via DCON protocol. There are many different selections with combinations of digital inputs, digital outputs, analog inputs, and analog outputs. Zigbee I/O modules can be configured via the dip switch settings on the module itself or via free utility. The utility does require a host coordinator to configure. Our free ZT configuration software utility, which again requires a host converter, can be used to configure the wireless I/O modules, safe values, digital inputs, digital outputs, analog inputs, and analog output pair configurations as well. The table shown shows our current Zigbee I/O module offering. We have many different combinations including RTD and thermocouple type, as well as combinations of digital inputs, digital outputs, analog inputs, and analog outputs. The list of I/O modules and combinations of I/O will continue to grow. All of our Zigbee I/O modules, including the ZT2042, follow the wireless standard Zigbee 2007 Pro, have operating temperatures of -25 to 75 degrees C, and have data communicable via Modbus RTU or our DCON protocol. Zigbee modules can be easily configured using the dip switch and rotary switch as shown. Each individual Zigbee I/O module or slave device must have its own unique node ID. This is set by the rotary switch and the very first dip switch, which signifies the most significant bit. The protocol is selected using the second dip switch, either DCON protocol or Modbus RTU protocol, a checksum setting, and a PAN ID and RF channel. All Zigbee modules must be on the same RF channel to communicate to each other. You can also have multiple Zigbee networks with different channels. Because Zigbee shares the same channel selection or frequencies as Wi-Fi and many RF devices, the ability to change RF channels to avoid interference can be a great benefit. Here's a chart showing the Zigbee channels available. Like I said earlier, many Wi-Fi and RF devices share these wireless frequency bands in the 2.4 gigahertz range. Because of this, you want to avoid interference between these devices. Many cell phones have network analyzers which will tell you what Wi-Fi channels are being used by other devices so you can avoid using these channels. We also provide a list in our manual which shows some suggestions. If you have multiple Zigbee networks, you can select different channels and have multiple networks running at the same time. The LEDs shown on the module provide convenient troubleshooting status for the Zigbee modules, including the PWR, which will blink steady if the watchdog is enabled or if there's a firmware problem. The Zigbee light or LED shows signal strength and is used for troubleshooting lost nodes within the network, and we also provide individual LEDs which show the status of the digital inputs and digital outputs for that particular module. I/O pairing is a feature we recently introduced to our Zigbee series. This module requires custom firmware built into one of our standard Zigbee I/O modules designated by an IOP at the end of the part number. This requires at least one IOP module. The IOP module acts as a coordinator and communicates to the I/O device. Digital outputs are triggered based on digital input status. So directly when a digital input is triggered at one end, the corresponding digital output at the other end is triggered, and vice versa. This can be configured using dip switches, but for more advanced communication or configuration requires a host converter. For pairing applications, you must have at least one of the following IOP modules. These modules act as coordinators and communicate to the Zigbee I/O modules as shown in the picture. Here's a list of the 4 currently available modules. We will be developing more shortly. Our I/O pairing modules look the same as our Zigbee I/O modules because they are the same, with different firmware installed in these modules. The IOP is part of the part number, and these do share the same operating temperature, frequency, and compliance range as our Zigbee IO modules. They have a wireless transmission range up to 700 meters line of sight and are DIN rail mountable and have surge and ESD protection. Here's a very simple yet useful application. The ZT2052 IOP module is connected to a digital input. When the digital input from this process controller triggers an alarm condition via its DO, it will trigger an alarm condition at a remote site with the alarm connected to the digital output of the ZT2042. And this is using our IO pairing modules. Our Zigbee IO pairing modules have been used in many applications in the building, factory, and machine automation fields, as well as for remote maintenance, remote diagnostics, and for test equipment. The diagram shown shows how our pair modules work in a one-to-one situation. The ZT2060 IOP continuously polls the ZT2060 for its IO status and updates its status of its digital outputs based on the status of the digital inputs from the ZT2060 and the output statuses of the ZT2060 when the digital inputs for the ZT2060 IOP are changed. For simple one-to-one pairing applications, configuration can be very simply done using the rotary switch and dip switch settings shown here. The ZT2060 IOP on the left settings are the default. Simply match the RF channel, PAN ID, and assign a unique address to the ZT2060 and your configuration is complete. You're also able to pair multiple Zigbee IO modules to form a multiple pair to one IOP module, as shown in the picture. The digital inputs will be followed by all of the Zigbee IO modules, but only the first one, node address 1, will be followed by the outputs of the ZT IOP. More advanced configurations can be also configured using the utility. Here's an example of how the previous application would be configured using the dip switch and rotary switches. Note that each individual IOP module has an address of 1, but the Zigbee IO modules must have its own unique address. So therefore in the picture, 1 and 2, and the RFID and PAN ID must match that of the host or IOP module. The IOP modules also have the convenient LED status for troubleshooting and checking connectivity. Note the power light being the most significant with this. It can tell you specifically which Zigbee slave module communication has been lost with, as well as provide this same digital input and digital output status LEDs, as well as Zigbee connectivity light for convenient troubleshooting. Because of the popularity of our Zigbee IO modules with our pairing feature, as well as customer feedback, we also developed a third series of Zigbee IO modules. This series is our IOG module, which stands for IO groups. Logic can be applied in the pairing, as well as synchronization is done periodically, so larger groups of Zigbee IO modules can be added to the network. Configuration can be done by dip switches, but traditionally for these applications the utility is required, as well as a host module is required to configure by the utility. The diagram shown in the top right shows how our ZT-IOG modules work. Digital inputs are read in by the ZT-IOG, triggering a series of relay outputs to be set using our Zigbee IO modules, as well as different Modbus communication done to the PLC and to other Modbus R2 slave devices. Logic can be applied to these digital input conditions to trigger different outputs and relay configurations based on the inputs. Our current offering of Zigbee IOG modules is shown in the table. We have digital inputs and digital output configurations of many sort, and again these also run logic and can be paired with our ZT IO modules as well as other Modbus RTU devices using our ZT2071. Our Zigbee IO modules can also be used with our free Easy Data Logger software package. Traditionally, they've worked with our M7000, our TM series, and our ET series. But now we do have the ability to connect our Zigbee IO modules as well. Okay, for this application or sample, we'll assume that I have a ZT2550 connected to my computer. The picture shown shows that it's RS-232 as well as RS-485. Connected to this, I will connect wirelessly to a ZT2060 to provide relay outputs and digital inputs that will be read in by Easy Data Logger. I'll follow this diagram. The ZT2550 will be connected to my PC, and I will be reading in analog inputs from the ZT, well actually I'm sorry, it'll be digital inputs and digital outputs from the ZT2060. Not quite shown in the picture, but it will be node ID 1. Okay, this is our Easy Data Logger software. The first thing we must do is install our driver, shown in the top left for the driver list. And this can be done very easily in DCON or Modbus RTU format, the default being DCON, but I'll also show you Modbus RTU shortly. The first thing you want to do is click on the Install button, select the mode of the driver. In this case, we'll be connected to DCON protocol. I don't physically have a device connected, so we'll just go by the default, which we'll leave the COM port blank for now, but you can simply click the Install button and then click the plus device to add your device. Note the radio buttons shown for the different formats. For this series, since we're doing ZT2000, we will select the radio button and select the module ZT2060, which we've shown. On the left side, you'll note that you can specify the address of the specific ZT2060, or you can also manually adjust the number of digital inputs, digital outputs, analog inputs, and analog outputs. Then we simply do that, and we'll see the tags shown here for the digital inputs and shown here for the digital outputs. Simply highlight the modules or the I/O you want to select or log and click the Add button, and note they'll appear on the right side. Once they are shown on the right side, you can also, well, actually I'm going to show you how to do Modbus RTU configuration in the same way. Let's see, first we must delete the previous tags. So delete the device and delete the decon. Now to install Modbus RTU, simply select Modbus Serial, and again we don't have a COM ports, so we will just click Install. Next we must select our Zigbee IO module. This time with the dip switch would have to be set for Modbus RTU protocol. We'll select ZT2060, and this time it will be a Modbus RTU connection with the similar 0 to 4 digital outputs, or 0 to 3 for a total of 4, and 0 to 5 digital inputs for a total of 6. Again, we highlight and select and add the channels to our list on the right side, and we click Home to go to the home, and normally click Start if you actually had I/O, but I'm just going to click on Simulation to show you what it would look like. You'll see there's track 1 and track 2 at the bottom. This would represent our digital input and digital output statuses. You do have the ability to select which channels are shown in which track by clicking on the track button. It will toggle between the 1 and the 2. And you also have the option to disable other IOs from being viewed at this moment to study or analyze a specific channel or channels. This concludes our presentation, but if anyone has any questions, please feel free to ask. If there are no questions, then we'll look forward to seeing you at our next webinar next month. Thank you for attending, and we'll see you next time.